Good morning, everyone. Thank you for joining. Thank you for making time to attend this webinar today. We're going to be discussing how to master facility asset management within ArcGIS Indoors. So we're implementing ArcGIS Indoors for a lot of customers, and this is a common challenge, is how to get that asset data into the Esri Indoors environment and then open up all the possibilities you can do with once you have your asset data attached to your GIS system. So firstly, I'll give an overview of what we'll be covering today. We'll start with an intro into enterprise asset management systems, what they do, what they're good at, and provide some examples of those. Then we'll go over the importance of data integration, why it's critical to make sure your asset data is available to other systems and vice versa. Next, I'll discuss the role of GIS in asset management and in facility management in general. We'll go over some best practices and strategies for asset data management. Then I'll present some of the key data integration methods that we use here at CloudPoint. And finally, I'll cover how we recommend managing your asset data in GIS, specifically within the Esri ArcGIS Indoors product. And as I mentioned, we'll go over some demos at the end and how we've implemented this into indoor mapping apps. So what is enterprise asset management? Well, for those of you who manage buildings or multiple facilities across a campus or a number of different facilities that have assets that need tracking, you're probably very familiar with your enterprise asset management system. It basically tracks your physical assets throughout their life cycle, tracks an asset from its procurement to installation to deployment, operations and maintenance, servicing, and then eventual decommissioning and replacement of that asset. So it essentially, your asset lives in that system throughout its life cycle, and has an asset tag or ID attached to it for that entire time. EAMs support scheduled maintenance work, work order management, inventory performance monitoring, and compliance and risk management. For example, your EAM can tell you how many fire alarms, smoke detectors, fire extinguishers, emergency lighting, etc. do you have within a certain facility? Are your electrical access panels, circuit breakers, and backup generators, do you have enough to comply with local, state, and federal regulations and codes? And they also inventory your accessibility features like ramps and signage and emergency exit signage to make sure your facilities are compliant. They are typically supported by structural relational databases behind the scenes, and EAMs are designed to be open and accessible to third-party integrations to read or write data to other systems. It's one of their main selling points. Examples of EAMs are IBM Maximo, Infor, SAP, Oracle, AssetWorks, Upkeep. A lot of different vendors out there offering asset management solutions. All of them, as I said, are very open and they make it very easy to integrate with their systems. A lot of our customers we're finding in higher education are using AssetWorks. So that's something we're trying to work closely with. So moving on, why is data integration so important? This sounds like an obvious question, but let's look at the main reasons. Your asset data is critical across the entire organization. It's very useful for nearly every other business system on your campus. It's used by resource planning, financial management, HR systems, maintenance systems, and a whole host of other systems, which we'll see on the next slide. So accessing your asset data in real time is crucial to enabling efficient decision-making across your organization. Making a request to your asset management department for a data export and then waiting for a formatted spreadsheet and then sharing copies of that spreadsheet around just doesn't really cut it anymore. But in many situations, I'm sure you've experienced, that's still the case, where your asset data will be exported out of the system and handed over in a spreadsheet format. And then it's essentially a snapshot of the current status of your assets. So by integrating that data seamlessly with other systems, you reduce data redundancy and duplication. You ensure that there's seamless operation across departments, and you eliminate data silos. You ensure that your asset data is the source of record for asset information, and this creates efficiencies, which reduces costs and improves decision-making. So this diagram sort of shows how enterprise asset management is really integrated and used throughout organizations. All these other business systems rely on asset information to answer their various queries. If we can just sort of go around the circle, you've got obviously the enterprise asset management at the top. Enterprise resource planning systems use this data for tracking costs of an asset, depreciation costs, replacement, repairs. They do budgeting and capital planning to ensure funds and personnel are available when your assets need maintaining or replacement is due. And you can run expenditure forecasts and report future costs. So it's critical that your ERP system has a direct link to your EAM system. Computerized maintenance management systems are used to create maintenance schedules, assign work orders, manage your inventory, plan day-to-day maintenance. Customer relationship systems use asset data to improve customer satisfaction and manage customer support requests. It feeds into your document management systems, business intelligence tools. We could continue going around the circles. Basically, all of these systems show that asset data is in huge demand across an organization. I mentioned Internet of Things briefly. IoT sensors are becoming increasingly important as this technology allows for more real-time data feeds to be sent back to the business systems, whether you're monitoring performance of heating and cooling, temperature, humidity, energy consumption, air quality, etc. So all of that sensor data needs to have a connection to your main source of record with your asset management. You may notice one system that we haven't mentioned here, which obviously this presentation is geared towards, is the GIS. As GIS professionals, this is where we see ourselves in the middle of everything, sort of tying it all together. We like to think we're sort of the center of the universe. Now, there's an argument to be made to put your asset management system at the center of the diagram. However, GIS is unique in the way it ties all the various elements of facility management together. It provides a single pane of glass, as a former manager used to put it, that provides an interface into which all the other systems information can be brought together and visualized. Another analogy is the spider in the web, where GIS is kind of connected to everything and kind of pulls the strings and can pick the flies off the other systems, but maybe the single pane of glass is more appropriate. So moving on, GIS can benefit asset management by providing that visual piece of information, the geographic context to your assets. Accessing asset data in GIS opens it up to all the spatial analytics tools you have in GIS. For example, how far is the nearest accessible entrance from each room? How many fire extinguishers are located on each floor? How many electrical panels? How far are they from the emergency exits? Can be used in site selection to find the optimum location for an asset placement, where to place a new HVAC unit or a solar panel or a Wi-Fi hub. It helps you prioritize maintenance based on areas with the most needs. Spatial analysis to look at what parts of your campus or your facilities require the most regular maintenance and prioritize targeting those areas. You can provide maps to your maintenance crews to showing the asset locations and turn-by-turn directions to navigate people to those assets. Allows you to map out the most critical assets for emergency response. So you can show on a map all of your most at-risk assets from natural disaster or other hazards. You can perform suitability analysis, check your asset locations for compliance with environmental and safety regulations. And finally, public engagement. GIS will allow you to create interactive maps for the public and other stakeholders to sort of showcase your resources and your asset distribution. The benefits to all this are, of course, enhanced decision-making, improved efficiency, better resource allocation, and of course, cost savings. But all of this relies on that data being updated in real time and the ability to access the most current asset data in situ without creating duplicates and replicas of that data and sharing that across the organization. So before we get to the demos, I just wanted to go over some data management strategies that we try to follow for our clients, some of the best practices and strategies for managing asset data and data in general for that matter. So avoiding data silos is key. Bottlenecks, duplication of data. This occurs when data is replicated and shared out of its system of record. It might be a spreadsheet or a table or a CSV export. As soon as that happens, you've broken the connection to the source data, obviously, and that is an issue, especially when you're trying to integrate data into another system like GIS. Are you now creating a copy of that data, and how do we push those edits back to the asset management system? So we try and take full advantage of APIs. As I mentioned, most of the asset management software out there, if not all of it, will provide very open APIs to extract, read, write data back and forwards into the system. We try to automate, obviously, as much as possible, data synchronization. If there are tables which have been shared between systems, to make sure that any edits to those tables, the data is pushed back into the system of record. And we have a lot of tools that will mention that ought to help with that synchronization. Establish common data standards across systems. So ensuring that whichever department is responsible for all of those various business systems that manage asset data, that they're all on the same page with regards to the data standards. So a universal asset ID, which is communicated and known throughout the organization, that doesn't change throughout the life cycle of an asset, that's that asset's code for its entire lifespan, throughout its deployment, operation, maintenance, and then decommissioning. That asset only goes away when the ID only goes away when the asset is finally decommissioned. And every system that references that asset ties back into that ID, which is it's really key. Quality assurance, enforcing data validation rules. We try to automate that as much as possible, whereby the IDs uniqueness is enforced and asset classifications are enforced. If there's any data entry, that data is run through a quality control check against the standard. You need a strong data governance policy for the organization, which establishes roles and responsibilities, who is responsible for updating your asset data, and change management policies that communicate any changes to that data governance policy, and provides continual training to new members of staff as to how your assets are managed throughout your organization. And then finally, just eliminate data redundancy, identify those systems of record, who is responsible for them, and where the version of truth resides. So as I mentioned, data integration, obviously highly important to reduce data redundancy, reduce duplication, push data edits back and forwards into the relevant systems. So these are kind of our favorite tools that we use here at CloudPoint for delivering data synchronization and integration. Obviously, direct connection to APIs. The Esri platform is very open in that respect, being able to access data tables and layers and feature services through APIs. Same with the major EAM software, IBM Maximo, AssetWorks, you name it. They all provide robust APIs, web-based solutions. FME is a software that we're using more and more. It's a very powerful tool for data integration. It has a lot of transformers built in, which connect to those APIs. If you have any colleagues who use FME, you've probably heard a lot from them about how useful it is and how powerful it is and how everyone should be using it. I'm one of those colleagues, so FME users do tend to go on a bit about FME, but it is very useful. You can automate processes and have them run as scheduled processes and have data replicated and synchronizing behind the scenes so that you get that seamless transfer of data from your asset management system into your GIS. The ArcGIS data interoperability extension is another tool we use, and that's basically FME rebranded and sold under from Esri. It essentially gives you the same capability when you open up that data interoperability tool within ArcGIS Pro. It launches FME, and you're building an FME workbench that can then be saved as a geoprocessing tool within your ArcGIS environment. So very useful integration there. Obviously Python and developing automated Python scripts which run using a Windows scheduler to, whether it's nightly or every morning or once a week, making sure that synchronization happens. OGC standards, obviously another option for sharing data back and forwards. Zapier and MuleSoft are different options for cloud-based sort of triggering actions within your system. So you can set up triggers, or zaps, as they're called in Zapier, which notify you if there's a new asset work order or a new asset record created in your system. I think Zapier only works with public applications right now. MuleSoft, I believe, can read between private applications. And then finally, Tableau and Power BI are two of the main data analytic platforms that integrate with GIS and asset data to bring that data into a dashboard. They can both be very useful. So just moving on to show how we integrate asset data into GIS, particularly the ArcGIS indoors data model. You can see here on the left-hand side of the screen, we've got our GIS data tables. The GIS asset record literally only contains the spatial attributes. So we try and make sure that the GIS handles all of the spatial data, and the EAM is the store of the non-spatial data. So there's only minimal information here in the GIS, which really is the asset ID. And then everything else is saying where that asset is, what facility, what level, what site, the X and Y coordinates, and importantly, the Z coordinate, the elevation. That's literally all you really need to manage in the GIS. And then if you have that asset ID, which links out to your asset data table, then the rest of the data about that asset lives in your EAM, in your asset management system. It could be the maintenance information, the performance, the past work order information. Your asset management system is the best place to manage that, and the GIS is where your spatial asset information will reside. You can see here that then links through facility IDs and level IDs, unit IDs, which are the rooms, into your other indoor GIS data layers. So that's kind of the approach we take, is really separating the spatial from the non-spatial data, and then maintaining that link with the asset ID, which is sometimes called like the golden thread to tie everything together. We don't try and duplicate those attributes over in the GIS. The main way we keep that separation is through relationship classes. You would build a GIS layer which has the location of your assets in 3D space within your buildings, and then you build a relationship class based on the asset ID to your asset information records, which in this case is an export from your asset management system, which that assets table then gets synchronized back to your asset database once any edits have been made. So relationship class is very useful for maintaining that separation between spatial and non-spatial data. So at this point, I'll just bring up some demos and show you how we've implemented this for some of our clients. So this ArcGIS Pro project it's a pilot study we did for the University of Texas at Austin. We took one building, the CAD data for that building, and loaded it into an Esri ArcGIS Indoors data model. Implemented the floor-aware data attribution so that then you have this floor picker, which allows you to filter your data layers between various layers within the building. You can see here we've got some asset data overlaid on the map. And these categories and subtypes are coming directly from their asset management system. This was actually a spreadsheet export that we've imported in here, but it could also be a live connection to that database. We've created the relationship class with the spatial data and attributed it with the level ID and the facility ID, and obviously maintained that asset ID link back to the asset information. This map basically gets published as a web map to ArcGIS Enterprise. And I'll bring that up to show how it looks. Once you have your web map published and you have your asset data overlaid, you can bring it into the ArcGIS indoor viewer. You can see we have the facility selector here on the side. We can scroll into various floors and look at the asset information. We can also navigate to various assets within our building. So now we have those asset categories that we set up in ArcGIS Pro. We can navigate to, for example, this HVAC control panel it will take us there. You can get turn-by-turn directions from other places on campus. It will show you, maybe a maintenance crew, show you how to get there, from how to navigate to that particular room within a building. The nice part about the indoor viewer is you can publish a web scene and look at your data in 3D. And then if you have the elevation values behind your assets, you can then also see your assets in 3D. And that kind of helps with the whole navigation experience of how you can show people how to get to that asset. Some of the other apps that we've built include a building asset editor app where you can actually create new features. You can drop a new feature on the map and then edit information about that asset, fill in the facility name, floor name, and then sort of auto-populate the required attribute fields. You can edit existing information. So these edits go back through that relational join to the asset data table, which would then be synchronized back to the asset management system. Other things you can do is a dashboard app, which allows people to browse your asset data and summarize it by floor. You can see here how it would look if you didn't have the ArcGIS indoors implemented. You've obviously got the entire building level stacked on top of each other, and only when you've built does it start to clear up, and you can get a clearer picture of your facility. We've also combined panoramic photos that were taken during a building survey with the asset data. So if I'm looking at this asset here in B4, click on one of the panoramic photos. That will bring up these 360 photos, which were taken during a LiDAR scan of the building. So you can see the LiDAR scanner here. It collected the panoramic photos, and that just gives your maintenance crews a better idea of what they're looking at before they maybe go on site, and allows you to explore the building. You can even look in classrooms and offices and find the photo which is nearest that asset and get an idea of what it looks like. I think we're running up against time. I'll stop there and go back to the PowerPoint slide, but that gives you a good idea of sort of how we've implemented this for other clients.